Sanibonani again. We are back with another video. This time we'll be doing question number 3. It is about the hyperbolic functions, and I believe after the lesson you will have gained something. And if you want more practice problems, more exercises or more activities, you are free to comment in the comment section below, and I will give you those practice activities. Today let's do question number 3. It says here we are dealing with hyperbolic functions. I believe you can see there it says the graph of f of x is equals to 2 over x minus 2 plus 3 is sketched below, not drawn to scale of course. And 3.1 says we must write down the equations of the asymptotes of f. I believe this is an easy question. Let's look at the vertical asymptote. We can see that x here is equals to 2, and they also told us there you just take the opposite of whatever is here. We can see that x is equals to 2. I'll be answering over here. For vertical asymptote, x is equals to 2, and for horizontal asymptote, y is equals to positive 3. Here we are given that here is positive 3 and y is equals to 3 here. 3.2 says determine the x and y intercepts of f. Let's determine those points. We know that the y-intercept, we let x is equals to 0. When we let x is equals to 0, we end up with an equation like this: 0 minus 2 plus 3. This will give us minus 1, and minus 1 plus 3, it gives us 2. Therefore, the coordinate, it will be 0 and 2. Let's put that into our sketch. Here will be 0 and 2. And when we are looking for the x-intercept, we let y is equals to 0. When y is equals to 0, we end up with an expression like this: plus 3. We move this plus 3 to the other side, it becomes minus 3 is equals to 2 over x minus 2. We cross multiply, we get that minus 3x minus 3 times minus 2 gives us positive 6 is equals to 2. And when we move this 6 to the other side, it becomes minus 3x is equals to 2 minus 6, it is minus 4. If we divide both sides by minus 3, we get that x here is equals to 4 over 3, because this will cancel here. As a coordinate, we can say 4 over 3 and 0. Let's put that here. It's 4 over 3 and 0 here. Believe you understood that. Let's move to 2.3. 2.3 says, 3.3, why am I saying 2.2? 3.3. For which values of x is f of x greater than 2? You can see here, f of x is only greater than 2 when x is less than 0. If you put in minus 1, we'll get a value that is greater than 2. If we put on minus 5, minus 10, we'll always get values that are greater than 2 here. So we can say x is less than 0. Like I said, if you plug in any values below 0, we'll get a y value that is greater than 2. This is what it means here. And 3.4, we move on. 3.4, Determine the equations of axis of symmetry of F. When doing axis of symmetry, you have to know the coordinates of here, where these two asymptotes meet. You know that the coordinates of here are 2 and 3. There are two equations of axis of symmetry. The one has a positive gradient and the one has a negative gradient here. Minus x plus c. And we plug in the coordinates of the intersection of those two asymptotes to solve for c. Where we see y, put 3 is equals to 2 plus c. C is equals to 3 minus 2. Did I put it correct? It's y is 3 and 2. Yeah. 3 minus 2 is 1. Therefore, y is equals to, can put therefore y is equals to x plus 1. Let's do the same for this. 3 is equals to minus into 2 plus c. C is equals to, since this is negative, when it comes to the other side it becomes positive. Let's say 3 plus 2, it gives us positive 5. Therefore, y is equals to minus x plus 5 here. Yeah, let's move on to another question. 3.4. 3.4 says determine the equation of the, I think we'll do 3.4 now. 3.1, yeah, let's do 3.5 here. This is 3.5. Write down the range of f here. The range of f. You can see that f here. You can see that the y value of f here can be anything, but can never be positive 3. We can say y is the element of real numbers, of course, but y can never be equals to 3. That is your range there. And what about the domain? I know there are other ways to write the range, but I think this is the easier way. And let's do 3.6.